So today we're going to look at the second part of 7.1. And to start with, I just want to make sure that you understand how to rationalize when you have square roots. I talked about in class that if you have a square root in the denominator, it gets confusing because the square root sign and the fraction sign kind of run together. And also, we want to be consistent with our answers so they all look the same. So what we do is we get rid of a square root in the denominator by multiplying by 1. And the kind of 1 we multiply by is the square root of 3 over the square root of 3, just to get rid of that square root in the denominator. In the numerator, we can't multiply the 12 and the 3 because the 3 has a square root on it. So we just write 12 square root of 3. And then we write on the bottom, it would be square root of 9. But we know the square root of 9, which is 3. So this winds up being 12 root 3 over 3. And then that can reduce because 3 goes into 12. So we can write that as 4 times the square root of 3. I'm going to leave the others for now and move on to the trig. If you have questions on those others, please ask each other or ask me during class. There are some special triangles that you do need to know about. The first special triangle is a 45-45-90 triangle. What that means is that one of the angles is 90, one of the angles is 45, and since these two angles have to add up to 90 so that the triangle adds up to 180, this angle would also be 45. So what that means is that these two sides are going to be the same length. And now we can go to the Pythagorean theorem and we can say, well then x squared plus x squared has to be the hypotenuse squared. And if we finish solving that, we have 2x squared equals the hypotenuse squared. And that means that the hypotenuse is the square root of 2 times x squared. But we can take an x out of there, so we have x times the square root of 2. And so this relationship, whether you remember it because of the Pythagorean theorem or you remember it because it's always true about a 45-45-90 triangle, the hypotenuse is going to be the square root of 2 times the other side lengths. So I can use that information. So we're going to fill in the blanks here. The legs of a 45-45-90 triangle are equal. The two legs are going to be the same size. And the hypotenuse is the square root of 2 times the length of a leg. If we know the length of the hypotenuse to find the length of a leg, so we're going to go backwards, instead of multiplying by square root of 2, we're going to divide by square root of 2, and then we're going to rationalize and reduce the fraction. And what I mean by rationalize is we're going to do what we did up here where we multiply by 1, except it'll be a square root of 2 instead of a square root of 3. All right, so here are some 45-45-90 triangles. We want to find the sides that we don't have. So since this side is 6, this side is 6, and the hypotenuse is going to be 6 root 2. This one's a little bit harder. We know the hypotenuse, but we don't know the two sides. So we're going to take that 2 square root of 2 and divide by the square root of 2. And luckily, we don't have to rationalize this denominator because those root 2's go away. So that means that this side would be 2 and this side would be 2. So that's always true for a 45-45-90 triangle. There are a couple here for you to try. I'm going to encourage you to pause here and then go ahead and try those. Here are my solutions. So this side is 3 root 2. That means that this leg will also be 3 root 2. And the hypotenuse is going to be 3 root 2 times root 2. Since the square roots match, we can multiply those together, so we get the square root of 4. But the square root of 4 is 2, so this would be 3 times 2. That means that the hypotenuse is going to be 6. All right, now for this one, we know the hypotenuse, so we have to divide by the square root of 2. But that has a square root on the bottom. We don't like that, so we're going to multiply by square root of 2 over square root of 2 to rationalize. And we wind up with 9 root 2 over the square root of 4, which is 2. And that means that these two sides are 9 root 2 over 2. What you might notice is that dividing by the square root of 2 is the same thing as multiplying by square root of 2 divided by 2. All right, so we are going to use trig to find the lengths and measures in one of these special triangles. Ooh, everything's going crazy. Oh, this is the wrong one. We want this one. Sorry. So if you have a 30-degree triangle and a 60-degree triangle, the relationship that you have to know for these ones, and this one I'm not going to prove to you right now, but the relationship is that if you do sine of 30 degrees, and you can do that on a calculator, you would have the opposite over the hypotenuse. It turns out that sine of 30 degrees is a half, so that means that the opposite over the hypotenuse is equal to a half. If I multiply that times hypotenuse, I get that the opposite side is 1/2 the length of the hypotenuse. So I could replace this O with 1/2 of the hypotenuse. We could now use Pythagorean Theorem to solve for A, because we know 2 of the lengths, and that would be in terms of H. I'm not going to right now, but I can in class tomorrow if you're interested. But this last side length is going to be the square root of 3 over 2 times the hypotenuse. So if you know the hypotenuse, you can figure out the different side lengths based on that hypotenuse. The short leg is 1/2 the hypotenuse. Oh, nope. The short leg times 2 would be the hypotenuse, or the hypotenuse divided by 2 gives you the shortest leg. And the short leg times the square root of 3 gives you the long leg, or the long leg divided by the square root of 3 gives you the short leg. All right, so here are some examples on finding the missing side lengths in these special triangles. These are special because we know one of the angles is 60, so right away we know the other angle is 30. And that means that we know that if the hypotenuse is 10, the short leg has to be 10 divided by 2, which is 5. And we know that the long leg, the one opposite the 60, has to be 5 times the square root of 3. All right. For the second example, we know the long leg. So if we know the long leg, we have to divide by the square root of 3. So 9 square root of 3 divided by square root of 3 would be 9. And then the hypotenuse is going to be twice as long as that. So it's going to be 18. So these are the answers for this one. These are the answers for this one. Oh, I didn't write them in the blanks because I was too zoomed in to even see the blanks. But x here would be 5 root 3. Y would be 5. And u here would be 18. And v would be 9. All right, so these ones I have here for you to try. pause first and then restart the video so that you can try it. Okay, so the hypotenuse is 16. That means the short leg is going to be half of that, and the long leg is going to be 8 times the square root of 3. So that means x is 8 and y is 8 root 3. And then this last one, if the long leg is 9, then the short leg is going to be 9 divided by root 3. But we don't like that because there's a square root of 3 in the denominator, so we're going to multiply by square root of 3 over square root of 3. So that winds up being 9 root 3 divided by square root of 9, which is 3. So it's going to be 9 root 3 divided by 3. So that means that my short leg, if I reduce this, is going to be 3 root 3. And then my hypotenuse is going to be double that, so my hypotenuse would be 6 root 3. So that means m is 6 root 3, and n is 3 root 3. All right, so today we're focusing on triangles that have special relationships. And the special relationships, we have 2 special relationships that we have to know about. One type of triangle is this 45, 45, 90 triangle. And in that case, the hypotenuse is square root of 2 times the side length, and the other 2 sides are the same. And the other relationship is, so that's this relationship here. If you know one leg of a 45, 45, 90 triangle, you know everything. Or if you know the hypotenuse, you can divide and figure out what the legs are. And then the other relationship that you need to know is this 30, 60, 90 relationship, where the opposite, the 30, is half the hypotenuse, and then the long leg is going to be 8, is going to be that short leg times root 3. All right, good luck, have fun today. Sorry I can't be there.